Very good morning friends, and in this video we are going to discuss more interestingly about implementing the idea of the limit with the help of some examples and developing the algorithm so that we can find the answers and we can apply the idea of the limit very easily. Now what is the algorithm? First, before that, I'm just giving you a little debriefing about the limit. What we have done till now is that limit x tends to a fx. So this is called the idea of limit. When x is tending to a, then where will fx approaching? So now suppose here I try to elaborate. I have, this is x-axis, this is y equals fx, and this is the graph of a function. Suppose I make it like that. Yes. And I'm interested in finding out the value of the function, like when x is approaching a. So x can approach a from the two sides, either from the left hand side, this is called the left hand limit, and from the right hand limit. The left hand limit, we write left hand limit LHL as limit x tends to a minus fx, and the RHL we write as limit x tends to a plus fx. Means when x is approaching a from the left hand side, means from this side, where will the function be approaching? And when x is approaching a from the right hand side, means from this side, where will the function be approaching? If I put the value of x directly into the function, then I get a situation called y equals fa. It means here, this is my fa. Now if you see that, suppose if I'm approaching a from left hand side, like from here, then where is my y value? Here. When my x value from here, from point, suppose I say this is minus 3. So this is my f minus 3. When I'm approaching minus 1, then this is my f minus 1. When I am approaching 0, means my function is approaching f0, which is here. When I go and find f1, so it means the function is approaching f1 here. And suppose there is f, slowly I keep on moving, and when I say that when x is approaching a, the function is approaching fa. Now from the left hand limit, if I say that just beyond a I take two numbers only, one number here, then the y value corresponding to this is here. Then I move here, then the y value will be here. Now you see, when I'm moving here, then the graph is coming in this way. When I'm moving from here to here, the y value is getting down, and when I'm moving from here to here, then the value of fx or y is going from here to here, and both seem to be meeting at this point from here to here. So we can say that if in this both cases, if the value of the function is fa and both these are same, then we say that the limit exists. Now when this limit cannot exist, suppose if I change this function, and I assume that this is not one uniform function but it is a composite function. Suppose it is something like this, then what happens? That when you are approaching and here, so when I'm approaching here, then the function is approaching here, and when I'm approaching this value here, then function is approaching this way. Now it is just stopping there, it's not coming down. So in this condition, it appears that this one fa, like the left hand limit, is not equal to, because there is a gap. There is a gap here. Okay, because function has been defined differently. So in that condition, limit does not exist. Now these are the graphical idea and the notations of the mathematical concept. Now how will we develop the algorithm to solve the situations? So let me clear this mess, or wait, instead of this I can develop a situation here. First I have to do that. In the case of left hand limit, you just assume here x to be a minus h, means try to find h which is very close to a minus x, means since my x is approaching a, so I'm just trying to get as much as close to a, and when I say that the x is tending to 0 minus, then h should be so close to 0 that because x is tending towards a, so the a minus h is tending towards 0. For example, suppose if x is tending towards 4, then if you assume that x equal to 4 minus h, so you get h equal to 4 minus x. So if x is going towards 4, very close towards 4, this is becoming something kind of 4 minus 4, close, very close, so that we can say that h is kind of 0. Not exactly, but indicating that it is becoming 0. So we'll use this idea here, and because of that we have to get rid of sign, and what our function become? Our function will become limit h tends to 0 and f. At the place of x you just write a minus h, so this will become a minus h. So now here you can approach irrespective of the sign, you can just directly continue getting your answers. Now here in this condition, in the RHL, you have to assume x equals a plus h. So what is the case? Then h is a minus x. Again we are doing the same thing, because x is tending towards a positive, so just try as much close to possible, so that if x is tending towards a plus, then h is tending towards 0, and then we can rewrite this whole expression as limit h tends to 0 f, and at the place of x you just write a plus h, and then you can continue without any sign concept, and then you can get your answer. Now I will take some examples to explain my point. I have a question that fx is mod x minus 4 over, make it x minus 6, mod x minus 6 over x minus 6 when x is not equal to 6, and 0 when x is equal to 6, and we have to discuss the limit at x equal to 6. So what we'll do, first we'll write left hand limit, limit x tends to 6 minus mod x minus 6 over x minus 6, because when x is 6 minus means less than 6, it means this is the case when x is not equal to 6, because x less than 6 is x not equal to 6. So here I put the same idea that I discussed just few minutes before, that x is a minus h, so we'll write x is 6 minus h. So let x is 6 minus h, so when x tends to 6, h tends to 0, then we get limit h tends to 0, and then we get mod. At the place of x you write 6 minus h, 6 minus h minus 6 over 6 minus h minus 6, and then you see you are getting limit h tends to 0, 6 cancel, that is mod minus h over minus h. You know that the mod of minus h will be positive h, so this will become limit h tends to 0, h over minus h, and the answer will be minus 1, because h over minus h is minus 1. Now same thing, if I apply the same idea in the case of RHL, then I find limit x tends to 6 plus, this is same equation because 6 plus is also not equal to 6. So 6 plus is just a little more than 6, cannot be equal to 6. So x minus 6 over x minus 6. Now you assume x to be 6 plus h. So when x tends to 6, then h tends to 0. Or when x tends to 6, because here you are getting h is 6 minus, x minus 6. X minus 6. So now the whole equation can be written as limit h tends to 0, Now you put at the place of x, you write 6 plus h, that is 6 plus h minus 6 over, that is 6 plus h minus 6. So you are getting here mod h over h. So limit h tends to 0, that is mod h over h, and mod h is h, therefore you get limit h tends to 0, h over h, and that is limit h tends to 0, 1, and which is nothing but 1. So now here in this case you saw that the left hand limit is minus 1 and the right hand limit is 1, and they are not equal, so we can say that since left hand limit is not equal to right hand limit, therefore our idea is that limit does not exist. I think I have made myself absolutely clear, and I will explain another example to clear your very concept. Now I have a question where the fx, not fx, just we write directly. Limit h tends to 0, e to the power 1 by x minus 1 upon e to the power 1 by x plus 1. And we have to discuss where, sorry, this is not h. So x tends to 0, and we have to discuss whether the limit exists in this case or not. So again we'll continue with our idea of left hand limit. So we'll write limit h tends to 0. I'm going a little direct. I will replace x by a minus h, and a is 0, so this will become e to the power 1 over 0 minus h minus 1 upon e to the power 1 over 0 minus h plus 1. So this becomes limit h tends to 0, e to the power minus 1 by h minus 1 upon e to the power minus 1 by h plus 1. Now I just try to reciprocate them. So limit h tends to 0, I write 1 over e to the power 1 by h minus 1 upon limit h tends to 0, 1 upon e to the power 1 by h minus plus 1. Now here you see that if h tends to 0, 1 by h tends to infinity, or becomes infinite 1 upon 0, and then 1 upon e to the power infinity, this term will become 0. So if I put the value h tends to 0, this quantity becomes 0. So I'll get minus 1 and then 1. So limit h tends to 0, and then I get minus 1 over 1. Do you see this part clearly? Minus 1 over 1. So here our answer is minus 1. So left hand limit's answer is minus 1. Now I go for the right hand limit, which goes like this, again under the light of the same algorithm, that we have to write x as a plus h. So I write directly limit h tends to 0, and then this becomes e to the power 1 over 0 plus h minus 1 and e to the power 1 over 0 plus h plus 1. So now limit h tends to 0, this is e over 1 by h minus 1 and e over 1 by h plus 1. Now e to the power 1 by h, since 1 by h tends to infinity, therefore e to the power infinity will also be infinity. So you are getting undefined minus 1, but we can just make it defined just by taking e to the power 1 by h common. So you get 1 minus 1 upon e to the power 1 by h upon, you take common here also, then 1 plus 1 upon e to the power 1 by h, limit h tends to 0. Now these two cancel. Since e to the power 1 by h tends to infinity and the 1 upon e to the power 1 by h tends to 0, so my answer is 1 minus 0 upon 1 plus 0, limit h tends to 0, which gives me 1. Now you see the left hand limit is not equal to right hand limit, therefore again we can say that the limit does not exist. This is how you can find the ideas of the limit, apply them in your given questions, and then you can solve them. Now again we'll take some more example, but that will be in the next video.